So engineers use a structured way to make decisions. Let's take a minute and think about how you make decisions, like what kind of club you might join at school or where you might go to college. Or think about the way teams that you're on make decisions. For example, how does your family decide where to go to eat? Or how do you negotiate with your roommates about what movie to see on the weekends? So I want you to pause this video and take a minute to think about how you and teams that you are on make decisions, and jot those down quickly. Some common ways to make decisions include an external champion. For an external champion, a boss or a client might make a decision. An example of this would be a teacher making a decision. Another decision-making process is using an internal champion. This is when an influential member of the team makes a decision. This might be a leader or a parent deciding which movie to attend. Another way to make a decision is by intuition, because it just feels good. Oftentimes, people choose to join clubs based on their intuition. A fourth option is multi-voting, in which each member gets several votes. And finally, another way to make a decision is using a pro-con list, where you list out the advantages or disadvantages of various options. Oftentimes, students select a college using a pro-con list. These decision-making processes are fine on a day-to-day basis, but this is not the way that engineers and engineering design firms make decisions. Instead, they use a structured decision-making process. Typically, engineers use a decision matrix to make decisions. This allows them to narrow a very large design space down and plan a path forward. So decision matrices are structured, they're evaluated rigorously, they're informed by data, and they're transparent and documented. Decision matrices are structured. There is a method for executing them, a defined process of how, which all types of engineers follow. This method or process can be followed by a team or an individual. Decision matrices are evaluated using pre-existing design criteria. Earlier, we talked about design criteria and their importance early in the engineering design process. Using a decision matrix, you will actually evaluate your solution ideas against these established design criteria. The process of using decision matrix also highlights the idea that there are not binary options, but rather that you go through and identify the relative strengths and weaknesses of your various solution options. Decision matrices are informed by data. Using decision matrices push engineers to use numbers and quantitative data to inform their decision making. These numbers can come from research, calculations, experimental data, or expert opinions. Use of this data removes the guesswork, feelings, and opinions of the engineering team. In other words, it's an objective process. But it should be noted that decision matrices are sensitive to their input data, meaning that the answers that they return are only as good as the data that informs them. And finally, decision matrices are transparent and document. The nature of making a decision matrices by setting up a table with an engineering design team almost by definition establishes the decision matrix is collaborative, open, and documented. And as a result, the decision matrix will be retrievable at a later date. So if you think back to the engineering design process, your team went through a period where they brainstormed a large number of ideas. The next step is that you need to evaluate those solutions and narrow them down from many solutions to just few or even one solution. After brainstorming, hopefully your team will have 50 or 100 ideas. It's really hard to go from these many ideas down to just one or two in one step. So instead, you need to think of this decision making as a series of steps. So you can see in this slide the idea of the iterative process of selection. You see on the left many ideas, which through various screenings reduces down to one or a few ideas on the right-hand side of the chart. The first strategy in engineering decision-making is to use common sense. Sometimes crazy ideas just really are crazy. And unless you can transition those crazy ideas into something that does make sense, the crazy ideas need to be removed. For example, you can't have solutions that break physical laws, such as a device that will only operate in zero gravity. The second strategy in engineering decision-making is to use a type of screening matrix. Here, the goal is to throw out low-fidelity solutions. A good screening matrix will allow you to eliminate 50 or 70% of your solutions. When you're using a screening matrix, you use your design criteria in an unweighted way. Some examples of screening matrices include the numerical evaluation and the screening Pew matrix. So the third step in engineering decision-making is to use some type of scoring matrix. The goal here is to select one or two great ideas that really meet your design criteria. When you're using a scoring matrix, you use your design criteria in a weighted way, unlike you did when you were working in a screening matrix. Some examples of scoring matrices include a priority checkmark and a scoring Pew matrix. So in conclusion, engineers make decisions in a structured, quantitative way. They use decision matrices to select a design and determine a path forward.